We're going to review factoring special products. So in the beginning of Chapter 9, we learned some shortcuts to these special products. These were special cases when we had something like a minus b times a plus b. Their product ended up being a squared minus b squared. When we had something like a plus b squared, their product ended up being a perfect square trinomial that was of the form a squared plus 2ab plus b squared. When we saw something like a minus b squared, we got a different perfect square trinomial that looked very similar. It was a squared minus 2ab plus b squared. So instead of recognizing that these factors come up with a special product, we are going to recognize the special product and work our way backwards to get our special factors. The first one that we're going to look at is this one. It's called a difference of squares because you are literally taking the difference of two squares. So if I have 9x squared minus 25, difference of squares is always going to be a binomial. So if you have a binomial that you need to factor, the first thing you're going to ask yourself is my first term a perfect square? And it is. In this case, 9x squared is 3x times 3x. And then you're going to ask yourself, is my second term a perfect square? And it is. I have 5 times 5. The last and most important question is, am I taking their difference? And in this case, we are. Since we have the difference of squares, we can apply our special product rule for factoring, where instead of a squared minus b squared, we are going to have a minus b times a plus b. So all that means is you're going to ask yourself, what is the square root of this? And we already said it's 3x. So 3x times 3x will get us 9x squared. 5 times 5 will get us our 25, and then we just have opposite signs. And this is your answer for factoring this difference of squares. I'm going to look at my two factors to make sure that I can't factor them anymore. 3x plus 5, they don't have a greatest common factor other than 1. They're not a special product, so that's good. 3x minus 5, they don't have a greatest common factor other than 1. They're not a special product, so I'm good. So this is my final answer for this difference of squares. Let's try another difference of squares. X to the 4th minus 16. So again, I have a binomial, so I'm going to ask myself, is this a perfect square? And it is. I have x squared times x squared. Is this a perfect square? It is. It's 4 times 4. Am I taking their difference? I am. So I have a difference of squares. So I immediately get to say, okay, x squared times x squared will give me x to the 4th. 4 times 4 will give me 16. Opposite signs. So this is my factoring of this difference of squares. Now I need to look at my factoring to make sure I'm fully factored. So here I have x squared plus 4. I'm noticing that both of these numbers are square numbers. This is a perfect square, it's x times x. And this is a perfect square, it's 2 times 2. But I'm not taking their difference, so I cannot apply this rule. They don't have a greatest common factor other than 1, so I can't break this down anymore. So that factor is good. Now I'm going to look at this factor. I'm noticing that they're both squares, and I'm taking their difference. So I can break this factor down even further, and I have to. I need to be fully factored. So my first factor stays the same. I can't do anything to it. And this is another difference of squares. X squared is the same as x times x, and 4 is the same as 2 times 2, and I give them opposite signs. So now I can't factor this anymore. I can't factor this anymore. and I can't factor this anymore. So now I know that I'm fully factored, and if I were to multiply all three of these binomials together, I would end up with this product. That's a great way to check your answer. Now we're going to look at perfect squared trinomials. So let's say I have 4x squared plus 20x plus 25. So if I have a perfect squared trinomial like one of these two, all I have to identify is it a perfect square? And if so, what is a, what is b? And I just get to write a plus b squared or a minus b squared. So here, if I'm going to be any perfect square trinomial, it's going to be this one because of my plus signs here and here. So I'm going to ask myself, is this a perfect square? And it is. It's 2x times 2x. Is this a perfect square? It is. It's 5 times 5. So if this is a perfect square trinomial, my a is 2x, because 2x squared would give me this. My b is 5, because 5 squared would give me 25. So now I need to double check with my middle term. My middle term should be twice the product of a and b. So 2x times 5 is 10x. 10x times 2 is 20x. So this is a perfect square trinomial. So my a is 2x, not 2a, and my b is 5. Since I have a plus here, I get to put a plus, and I'm squared, because it's a perfect square trinomial. And this is my fully factored form of the trinomial. Now it's important to note, if this number was different, let's say it was 21x. This is still the square of 2x. This is still the square of 5. 2x times 5 gives me 10x. 10x times 2 is 20x. That is not the same as my middle term, so I cannot apply my rule. I'm going to have to factor this like a regular type 2 trinomial, where I multiply a and c, find factors of that have a sum of b, that kind of a thing. I'm only allowed to use this shortcut because this is a perfect square trinomial, because it fits this pattern. Let's look at another one. 49x squared minus 14x plus 1. So if I look at a trinomial, I might ask myself, is there a greatest common factor I can factor out? And in this case, there's not. Then I'm going to ask myself, is this a perfect square trinomial? If it is, great, I get to use the shortcut. If it's not, I'm going to have to factor it like a type 2 trinomial. So in order to figure out if this is a perfect square trinomial, I'm going to look at my first term. Say, is this a perfect square? It is. It's 7x squared. And I'm going to look at my last term and say, is that a perfect square? And it is. It's 1 squared. So if this is a perfect square trinomial, I'm saying that my a is 7x, because 7x squared is my first term. And I'm saying that b is 1, because b squared is my last term. So now I need to check that my middle term is a times b times negative 2. So my a, 7x, times b, 1, is 7x. That times negative 2 gives me negative 14x. So this is a perfect square trinomial. So I get to write 7x minus 1 squared. Whenever there's a minus here, I write a minus here. Whatever the sign is of your second term, that's the sign that goes in your parentheses when you're factoring a perfect square trinomial. Remember, in the last one we did, this was plus and this was a plus. So that sign just kind of follows. And that's how we factor special products.